Cat's fired up. So, I don't know what that means, but this is the image I want. Blow it up a little bit. What's that, Jesus?
I said holy but Jesus.
How do I make plus? Yeah, there we go. So, this is a sampling of the distributions that are out there, like in the world. I mentioned before that we do two in here. We do the normal and the binomial, and that's it. And if you look up there, you can find them. If you look in there, you can find the binomial and the normal. Let's see. I may have to scroll down to find it. It's somewhere up there. Hang on, we'll find it. I may have to scroll. Hang on. There's your gamma function. There's your gamma right there. There it is. There's the normal.
And standard.
And right, and the standard normal's right there. So it's a subset. And what's kind of cool about this is they show you the transforms, like to go from the normal to the standard. Look at that. Those are the two formulas we use. Those are formulas we use to transform from normal to the standard normal. And back and forth. I mean, it's invertible. You can go back and forth. So to go this way, you have to use that one, and to go that way, you have to use that one. And we'll see more of that today. That's kind of the point of today, is to show you that back and forth. We're going to talk about more IQ scores and also some pregnancy lengths.
And they also use logarithm?
A logarithmic distribution, yeah. And there's all kinds of them. I've mentioned a few before. I never mentioned that one because it's pretty specialized. But there's the exponential distribution, which is a great one. This was a great one when you're talking about things like car headlights. It's called memoryless. It's got a memoryless. It's very, very cool. Let's see, other ones. The Poisson is up here somewhere. It should be tied to the binomial. Oh, there it is.
Binomial.
Yeah, the binomial. And what you'll notice is, do you see how many things are connected to these two? That's why I like those two in 243. If you can kind of deal with those two, you can branch off and get the rest of them. I've mentioned this one to you guys. Hypergeometric is when you can't satisfy the independent trials bit in the binomial. You have to use the hypergeometric. And then there's the geometric one, which is somewhere.
Yeah, I see.
Somewhere in here. I mean, obviously. That's a 244 distribution. We're doing that right now in 244. Then there's a T distribution, which should be, actually, it's probably just going to be its own. It's going to be, there it is right there. Boom. So, I mean, and I mean, these are wonderful. I mean, you don't think so, it's okay. It's a lot to deal with on a Wednesday morning after Memorial Day weekend. But the point is, though, if we can immerse ourselves in a couple, I mean, basically all of these come off of those two. So I figured let's just stick with the two most kind of like prevalent ones. And then if you ever need more, you'll pick them up when you need them. 244, we'll pick up three more, actually. We'll pick up the chi-square, the T, and the F, which is going to be a ratio of chi-squares, so it's going to be down there low, too. So, I mean, there are lots of them out there, and I'm sure there's even more than what's in this awesome graphic.
Geometric is right there.
Oh, you found geometric?
Yep. Pascal.
Oh, there it is, way over here. Here we go. Tied up the Pascal, which I don't even know what the hell the Pascal is. So somehow that's tied to the normal side. It's very, very cool. That's the binomial transform. Yeah, I don't know. I mean, there's so much I don't know about these things, way more than I do know about them. So, anyway, just to like a hey, that's what's out there.
Someone actually took time to systemize.
Well, this is essentially what a textbook is. If you think about it, this is a textbook. You strip everything out except for the formulas. Now imagine, on the first day of class, if I walked out and just handed you this. By the way, this is what we're going to do the next 10 weeks. I mean, mass vomiting induced, inches of vomit on the floor. Exactly, no. But I mean, and I've been trying my damnedest to hide these formulas. If you look up at the binomial, for example, you've got these equations for average and standard deviation. Well, that's actually variance, average and variance. And I've been hiding those from you because you don't need to use those. You do need to use these transforms between the normal and the standard. You have to use those. Those are important. Those are important because that's kind of what, well, there's no other way to do it conveniently. I guess that's what I'm getting at. There's no other convenient way of doing it. You have to do it with those. That's the most convenient way, is using those. So I've tried to hold as high as many formulas as I could from you, except for those two, because those two are actually pretty important. And those of you taking 244, which is maybe a third of you taking 244? Yeah, about a third of you. We'll be playing with those formulas the entire term. So just get used to seeing them, get used to manipulating them, and going from there. Cool? All right. So let's get back into those. Let's get back in. How was the actually, before we do that, how was the simulations project? Decent?
Yeah.
Decent, good. Good. Well, that's what's cool. Because most of it's set up for you, which is nice. I've been on this kick recently, ever since I've been going to these conferences where people are talking about Monte Carlo methods, which is what you're doing. It's called Monte Carlo because you're basically gambling. Essentially, every time you press F9, you're rolling dice. I mean, hopefully you kind of made that connection. Like you press F9, 6 more burritos. You press F9, 6 more burritos. Press F9, 10 more blocks. Press F9, another poker game.
Yeah.
You press F9, 50 more birthdays or something like that. So the idea is that you don't have to deal with these. If you don't want to, you can deal with that. As long as you can simulate those properly in like a computer spreadsheet, you can actually get extraordinarily close, as you saw, results to what's actually going on with this. Although that seems to be a little more approachable than this. I actually had a student in the other 243 class come up to me and says, dude, can we simulate like any game of poker? I'm like, well, yeah, if you look at the project number 3, he's like, oh my God, no! And he ran out the door to go check it out. I've never seen somebody so excited about looking at a project before. But that's the thing, like you can simulate almost anything as long as you know the constraints on what you're trying to simulate. I mean, this is what flight simulators are. When pilots train for flying, they're training on essentially, not an Excel spreadsheet, but they're training on essentially, is it going to rain today? Are we going to hit some turbulence? Are we going to, it's all die rolls. It's all die rolls. I actually just suggested, my grader Amber just handed me a bunch of stuff 5 minutes before class, so I don't have to get back to you yet, I apologize. I do have some stuff to get back to you here. But she said she's going to do a debate in her class where she models 2 businesses and she has folks argue which business they should invest in. And I said, well, that's awesome. That's totally, because basically there's no correct answer. And I was just like, well, yeah, but then we get done, and then they'll know which business did the best. I'm like, well, only if you know how the business does. I mean, at that point, you've invested money, but you're not sure how the business could tank. And I said, why don't you create a Monte Carlo over every term? Every term, collect data. Suppose that the business has a 90% chance of earning this much and a 10% chance of losing this much, and just let that do that for you. And she walked out thinking, oh my God, another great example of how to use this stuff. I mean, it's awesome. It's a very powerful tool. So I've been sneaking more and more of this. I'm sneaking my 105 students quite a bit. And I'm sneaking my 244. Pretty much every take-home exam now is going to have a component of that. Hopefully I can get one done for your last exam. Oh, I know how I can do it. Yes. So for your last exam, we'll have one too.
Actually, we did it practically the same in Business 101.
Good!
Yeah.
Good.
Because there was one assignment we had to decide and prove why we would invest money for our
Sure.
lowers, but
Absolutely.
not people, vice versa. So yeah.
And that's the course that Amber's doing right now is BA 101,
Okay.
or BA 104 actually, business math. But I said take it one step further and then see if your investment paid off. It might be a loss. And that's the thing, you have to understand like what an 80%, I'm going to turn this off.